Welcome to qnawire.
In this problem, we have to find the maximum velocity that a car B can go around a curve, given that we know the coefficient of static friction between the tires of the car and the road. So let's start this problem by drawing a free body diagram for our car, which is just this red dot that I've drawn here. So of course, gravity is pointing straight down, and since we're on an unbanked curve, so our ground isn't sloped at all, the normal force is just pointing straight up. Now the force of friction is going to be pointing toward the center of the circle. And that means that our force of friction must be what is responsible for our centripetal force. Because remember, the centripetal force isn't like gravity, which is a fundamental force which comes from the laws of nature. It is a force that has to be caused by something else. So in this case, that is the force of friction. All right, now lucky for us, we know an equation for the force of friction. It's equal to the coefficient of friction times Fn. And since Fn is opposing the gravitational force in this problem, as we just drew in our free body diagram, that must be equal to theta mg. So now that lets us write that must be our normal force times mv squared for r. And we don't know our value of m, but it doesn't actually matter in this problem because we can just cancel it out. From here, we can solve for v, which we find is equal to the square root of r times our coefficient of friction times g. Now we have to start thinking about what car we're actually talking about, right? So in this problem, we are given all of our quantities needed to solve for r when we're talking about car A. And if we know r, then we can plug into this equation for VB and just solve. So let's look at our car A and solve for r. All right, so 25 is our max V for car A, and that is going to be equal to r times our coefficient of friction, which is 1.1 from earlier, times 9.8 meters per second squared, which is g, our acceleration of gravity. Now when we solve this, we find that r is equal to 57.98 meters. Now, all that's left for us to do is plug into that same equation again, this time knowing r, but not knowing our maximum velocity, vb. So that is going to give us vb is equal to 57.98 meters times 0.85, that's our coefficient of friction, times 9.8 meters per second squared. And that is going to give us 21.97 meters per second, which is the answer to this problem.